Welcome to my channel. Let's talk about problem 66 in chapter 2. This is still a two-body problem. It tells us a rock is thrown vertically up with a speed 12 meters per second. So this is still up through problems. We choose up as positive directions. The initial velocity for object 1 is 12 meters per second. And the time taken is t. And then exactly 1 second later, a ball is thrown up vertically along the same path with a speed of 18 meters per second. So then the object through 1 second after with the initial velocity 18 meters per second. So initial velocity for the object 2 is 18. And the time taken for the object motion for object 2 is t minus 1 because it's 1 second later. That means if the object 1 moves 1 second, object 2 is just 0 second, moves 0 second, not move, right? If object 1 moves 2 seconds, object 2 moves 1 second. See, this is absolute problems. Acceleration is due to gravity always pointing down, so we must keep negative side there. In this one, ask you at what head will the collision occurs? The collision occurs, that means the displacement is same for y1 and y2. Do you agree? They meet at the same head. So in this one, we can write the displacement equation with object 1 and displacement equation with object 2. Their acceleration is negative g, and y1 should equal to y2, and then we make it simple. y1 should equal to y2, so then we input numbers. y1 is 12t minus 4.9 t squared, and y2 is this one, and y1 equal to y2. We need to solve this equation to find the t, and we find t is 1.45 seconds. And at what head will they meet, right? So we need to find y1. There y1 equal to y2, so y1 is we just look at it. Y1 is 12t minus 4.9 t squared, and input is a t, and then we find the displacement, the position for the y1. The second one asks you, answer question A and B. Assume that the order is reversed. The ball is through 1 second before the rock. So the ball is through 1 second before the rock. So in this one, we can see the initial velocity for object 1 is still 12 meters per second. The object 2 is still 18 meters per second. And then the time taken for this one, this is t plus 1 because it tells us it is 1 second before the rock. So 1 second before the rock. That means this object 1 moves 1 second. This should move 2 seconds, right? So this is t plus 1. And then we still write the displacement and time equation for y1 and y2. And then y1 should equal to y2 where they meet. And then we find input the acceleration as negative g, and then we write the equation for y1 equal to y2. This term should equal to this term, and then we solve this equation. We find t is 3.45 seconds. Can we see at this time they meet? Wait, right? We need to double check, and then we can see at what head will this they meet together. And then we try to find y1, and then we input this time t inside. We find, wow, it's negative 14 meters. It's impossible because we can say this is up through problems, either up and then it's down. It should stop at the y equal to 0 because there is the ground. It cannot move. It's impossible, and this one still moves up and then returns to ground. It's down. So this one is impossible, right? Thank you.